Okay, hello. This is a short video about transforming PLFD propositional logic for finite domains to propositional logic formula. Yep. So this is a PLFD formula, F. We're going to transform it into a propositional logic formula, G. So you might want to pause now, do that, and then play it again to see that you've got the right answer. Okay, so the first thing we're going to do is introduce a variable for each value in the domain of x and y. So for example, we introduce xa, propositional variable, to capture the fact that x equals a. Yep. And we use that to rewrite this formula. Okay, so most people got this right in the assignment. It's relatively straightforward. So ye implies yf equals xa xb or xc and p. Note p just remains p because it's already a propositional variable in f. Okay, so these look the same, but the question is, are they equivalent? Well, equivalence is about having the same models. So the question is, do they have the same models? And the problem here is that models for PLFD aren't the same as models for PL. Yet their kinds of interpretations are different. An interpretation of f is going to define for x, y, and p a value from their domain, and a model for G is going to define for xa, xb, xc, xd, ye, yf, and p a truth value, 0 or 1. Yep. So we need some kind of interpretation between the two, but we can do that because we're clever people. So we take a model for this, so x equals a, y is f, and p is 1. Yep, that's a model for f. So we can turn this into a model for G as you would expect, like so. So we're happy there. You can check that those are models later. But we might take something like this. Okay, that's a model for G. We're happy with that. But how do we turn that into a model for f? Because it says that x can be b or c. Well, that's not a valid interpretation in PLFD. Each variable can be at most one value. It says that y can be e or f. Yep, what's that? So what we have here is something that's a model for G, which isn't a model of f, which means they're not equivalent. So what we're going to need to do is add something to G to make this not a model for G anymore. Okay? And the thing we're going to add is something called domain axiom. Yeah? So why is it called a domain axiom? Well, it captures the information of this domain. So what information is encoded there? Well, it says that y has to be e or f, which means ye or yf needs to be true. The other thing is it says it can be at most one of e or f. Yeah? So, and it can't be both ye and yf. Yep? That's not allowed. Okay? So that's the domain for y. For x, it's pretty much the same, but it's a bit more complicated. Yep. So x has to be one of these things. Yep. And then we've got a whole load of formulas about x. So for all kind of x1, x2 in xa, xb, xc, xd, such that x1 is not equal to x2. That bit's important. It's not the case that x1 and x2. Yeah, so it's disjoint. And when we were doing the modelling earlier on in the course, we saw how to specify these kind of things. Yeah. So let's call that dy, that dx, and now add on at the end, and dx and dy. Now those are going to stop us from having that interpretation earlier that made these not equivalent. Okay, so the transformation process, introduce these new variables, rewrite the formula, and introduce the domain axioms for each variable. Okay, and the reason we need those domain axioms is to stop us having things which are models for this propositional formula which aren't models for the PLFD formula. Okay, so I hope that made sense. Thanks.